Well, welcome. My name is Mr. Murphy. In this video, we're going to be doing the second part of lesson 1.4. If you haven't already watched the video for the first part, you really need to do that. Because in this part of the video, we're going to be extending that one step further. Because in the first part of the video, we looked at sequences, arithmetic sequences to be specific. And in this video, we're going to be looking at series. And we're going to be looking at what's called an arithmetic series. So let's go ahead and let's start with that. Actually, before we do that, let's start with a warm-up. So I want you to review what we just did in the previous day, in the previous lesson. And so I want you to look at this sequence, the 20, 16, 12, and 8. And I want you to find a recursive definition, which is just another name for a recursive formula, an explicit definition, so an explicit formula, and also find the 10th term in the sequence. So you want to remember which one of the formulas that you find will be the best one to use to find that 10th term. So why don't you guys go ahead and pause the video and hit play when you're ready to check to see if you've done this warm-up activity correctly. All right, let's see how you did. So first off, you should recognize that obviously the first term is 20, but what we're doing here as we progress from one term to the next, we're subtracting 4 or adding -4 each time. So our recursive formula we would define like this. So we would have a sub n equals, then that fancy bracket, and then we would define that first term being 20, and then after that first term, the n is greater than 1, we would have our previous term, a sub n minus 4, or a sub n minus 1, plus -4, or you could just say -4. So that would be your recursive formula. So hopefully you did that one well. All right, let's check to see what you did on the explicit formula. So the explicit formula would be written in this form, or you could have simplified it, but in general, we would just have it like this. So where your constant difference would be a -4 times n minus 1 plus that first term, which is 20. If you did take it one step further and simplify it, you'd have -4n plus 24. Because -4 times -1 would be a +4, and 20 plus 4 then would be plus 24. So those are your two formulas. Now to find that 10th term in the sequence, we wouldn't want to use the first one. I mean, you could, but it's just going to take longer because you're going to have to find we already have the first 4, but then you have to find the next 6 to get to that 10th term. Otherwise, to find the 10th term, the easiest way to do it would be to use that explicit formula. Just put 10 in for n. So 10 minus 1 is 9, and 9 times -4 is -36, and -36 plus 20 is -16. So the 10th term would be -16. So hopefully you got all three of those parts correct. All right, so now let's define what a series is. So specifically, we're going to be looking at what's called a finite arithmetic series. The word finite just means it has an end to it. So this is going to be, in a series is a sum of the numbers in a sequence. So a finite arithmetic series is going to be the sum of the terms in a finite arithmetic sequence. So this is where we're going to know a specific amount of terms for a sequence. Like we're only going to be using the first 7 terms of a sequence and adding them together. And that's it. That's all you got to do. So to find the sum of an arithmetic series, we're going to use this formula. Now let's identify some pieces there. Now first off, that denominator, let's start in the bottom. It'll always be divided by 2. Because what we're doing is we're finding the average of the first and last term and multiplying the average of those, or I should say we're taking the first and last term and multiplying it times the number of items in the sequence, so the number of terms in the sequence, which is n, and dividing by 2. All right, so essentially you're finding the average of the first and last terms multiplied by n is another way to find it. So again, the n represents the number of terms in the series. The a sub 1 represents the first term. The a sub n is referring to the last term in the sequence, or in the series. All right, so let's look at an example. It says here, what is the sum of the terms in this arithmetic sequence 1, 4, 7, 10, and 13? Now I know, you could just get out a calculator and add together 1 plus 4 plus 7 plus 10 plus 13 and get your answer that way. But we're not always going to be working with situations that are going to be that simple. So you need to know how to use the formula, even in these really easy situations where we could just add the 5 numbers together. So here's how we would do that. We would identify our first and last term. So our first term is 1, our last term is 13. And then we count up how many numbers we have in that sequence or in that series. We'd have 5 numbers in that series. So n would be 5. So 1 plus 13 is 14. 14 times 5 would be 70. And half of 70 is 35. So the sum of that series would be 35. Let's look at the next one. The next one gets a little trickier. It says, what is the sum of the terms of an arithmetic sequence with 10 terms and a first term of 3 and a 10th term of 35. So this is why we need to know how to use that formula. Because I don't know all the terms. All I know is the first term and the 10th term. And the fact that we're using only 10 terms. So we're just going to plug those numbers into that formula. So the number of terms, like I said, was 10. Our first term is 3. Our last term is 35. Our 10th term is 35. So if we add those together, 3 plus 35 would be 38. 38 times 10 would be 380. And 380 divided by 2 would be 190. So the sum of that series would be 190. Simple. That's all it is. Now it's your turn. So why don't you guys go ahead and do the same thing for these two. Again, with this first one, please don't just add together 5 plus 11 plus 17, because this one, even though it'll give you your answer, believe me, using the formula will make it a lot faster to get the sum of that series. And then you have to use that formula to find the second part. So why don't you guys go ahead and pause the video and hit play when you're ready to check to see if you've done it all correctly. How'd you do? Let's check. All right, so for the first one, this is how you'd set up your formula. Because we know if you count up, there's 7 terms in that sequence. So the number of terms in the series is going to be 7. We know the first term is 5, the last term is 41. So we would take 5 plus 41 and get 46. 46 times 7 would be 322, and half of that would have been 161. So some of that series would be 161. Did you get that? All right, good. All right, let's look at the next one. The next one says, what is the sum of the terms of an arithmetic series with 12 terms, and a first term of 3 and a 12th term of 25? All right, so this one, like I said, you have to use the formula. So we would plug it all in with our number of terms would be 12, our first term is 3, our last term is 25, and divide by 2. So again, 3 plus 25 would be 28. 28 plus, times 12 would be 336. And if we were to take half of that, we would get 168. So that is the sum of that particular series. So hopefully you got those two correct. Now we need to move on to something different. Okay, there's a way that we could represent a series using what's called sigma notation. Now that giant Greek letter looking E, that is actually the capital letter for sigma. Okay, so this is why we call this sigma notation. Now that letter, that symbol for sigma, represents the sum. If you're ever working with an Excel document and you want to find the sum of a bunch of cells, you'll actually find one of the symbols, one of the tabs at the top would be that sigma. So if you click on that button, it automatically knows that, you want to find the sum of a bunch of cells. And so it'll automatically do that for you. So that's what that sigma represents, is the sum. Now, the bottom there represents what we call the index. Okay, that tells us where our series, what term in the series we're going to be starting with. Now, most of the time it's going to be starting with the first term. So almost always we'll see like I equals 1. They don't always use I, sometimes they use N, but it's always either I or N that they use. And so they'll say I equals 1 or N equals 1, meaning we're starting with our first term in the sequence. Now, at the top of sigma, that's going to be, now this is where it gets tricky, the last term of the sequence, not the value of the term. Okay? So if we're going to, or I said sequence, series. It's not going to be, so it's going to be like if we had 10 up there, that would mean that we're adding together from the first term to the 10th term in the series. It doesn't mean that the last term is 10, it's just that we're using the first term to the 10th term. Okay? Or if the top number is 12, it would just be going up to the 12th term. Now to the right there, that gives us the actual value of each term in the series. Now if it just says a sub I, that just means that we're leaving every term as they are. We're not going to do anything with them. But sometimes we might have something in parentheses, like we might have a sub I plus 5. That just means you take each term and add 5, and then add all those terms together. Or if we had 2n minus 1, we would take 2 times each term, subtract 1, and then add them all together. So again, like I said, so that a sub I can be replaced with the explicit formula for the sequence. Okay, so let's look at an example. So let's say if we had that previous series 1, 4, 7, 10, and 13, we can write that 2 different ways using sigma notation. Let's look at the first way. So this would be the first way, okay, where this form is only useful if we know the actual series. Okay, in this case we do, because we know the actual numbers are 1, 4, 7, 10, and 13. But notice none of the values of the series are in this notation. So if I didn't know those 5 numbers, using it in this way is not going to help me at all. Okay, because I don't know what the first term is. I don't know what the second term is if I didn't see the list in front of me. So that's why we need to be familiar with another form of sigma notation, and that's this one. And this is where we use the explicit formula. So this is where if I didn't know those terms of the series, we could use the explicit formula to get each of those values. Okay, like I could put 1 in for I, so 3 times 1 is 3. 3 minus 2 would be 1. So there, we got our first term of 1. To find the second term, I would put 2 in for I. So 3 times 2 would be 6. 6 minus 2 would be 4. So there's your second term in the series, and so on. So that's why we need to be, so that second formula, to be honest with you, is the one you're going to be using more frequently. All right, so here's an example where we're going to do just that, where we're going to find the sum of the series. We don't know the actual values in the series yet. And you know what? You might be thinking, oh my gosh, I'm going to have to write down all 9? No, because remember, in the sum of a series, we only need to know the first term and the last term. So from this notation, we know that there are 9 terms of the series. And we have that explicit formula there. We're going to use the explicit formula. Like I said, we're going to find the first and last terms. We don't have to find all of them, just the first term and the last term. So the first and the 9th. So to find the first term, we would put 1 in there for I. So 2 times 1 is 2, and 2 minus 6 would be negative 4. So to find the last term in the series, which would be the 9th term, we're going to put 9 in there. So 2 times 9 is 18, and 18 minus 6 is 12. So the first term is negative 4, the 9th term is 12. So now we can plug all that information into our formula. So again, we'd have 9 for a number of terms, and then negative 4 plus 12 all divided by 2. So negative 4 plus 12 would be 8. 8 times 9 is 72, and 72 divided by 2 would be 36. So some of those terms would be 36. Even though we don't have them all in front of us, it doesn't matter. We found what we needed, and we got our answer. Let's look at this one. So this one, it says, how can we write this series 2, 9, 16, all the way up to 79 using sigma notation? Do you notice something wrong with this picture? We know the first term, and we can easily find the common difference, because from 2 to 9 is 7, from 9 to 16 is also 7. And we can use the last term to find n. We need to figure out how many terms there are in the sequence. So we're going to use the last term to figure that out. So we have to use a lot of what we've learned now in this entire lesson from what we did in the previous video as well as this one. So let's start by finding an explicit formula. Okay, so we know the first term is 2. We know our constant difference is 7. We know the last term is 79. So we need to figure out what n is. So using that explicit formula, we're going to plug each of those numbers in. Notice the color coding I've done there for you to make it easy to see where we plug each of those numbers in. So now we're going to solve that. I'm going to distribute the 7 through. So if I did that, I'd have 7n minus 7, and then I would combine like terms. Okay, negative 7 plus 2 would be negative 5. Now I'd add 5 to both sides, I get 84. Divide by 7, we get 12. So that tells me there's 12 terms in that series. Well, remember, that's not what they're asking for. They're asking to write this in sigma notation. So to put this in sigma notation, we're going to combine that explicit formula with sigma notation. So we know we're going to start with our first term. We're going to end with our 12th term. We're not actually going to put the value, just the fact that we're going to end with the 12th term. So 12 would go on top of sigma. And then to the right of sigma, we would write our explicit formula. So that's how you could write it. Another way to write it would be to simplify that right side. So we could distribute the 7 through and write it like this. So we would have 7i minus 5. And be honest, writing it in simplified form is the more common way you're going to see these. So you want to be familiar with that. And also notice that I replace n with I, just to be consistent with the fact that in the bottom of my sigma, I have I equals 1. I could have fixed that by instead writing n equals 1. It really doesn't matter. All right? But that is how you'd write that using sigma notation. All right, so this is just taking that one step further now. If you notice, we're still dealing with the same series, but this time it says there at the top, it says, what is the sum of that series? So now we're going to just take what we've learned, that the first term is 2, the last term is 79, and that there's 12 terms now in that series, and then we'll divide by 2. So so we're going to use that formula. So we'd take 2 plus 79, which would be 81, and 81 times 12 would be 972. Use your calculator, don't worry, I didn't do that all in my head. 972 then divided by 2 would be 486. So that's how you could find the sum of that series then once we know all that other information. All right, now it's your turn. Okay, so I want you guys to take a minute. I want you guys to figure out what the sum of that series would be. So you're going to have to find out, just like we did in the previous one, what the first term would be, what the last term would be, and then use that sum of a series formula. So I want you guys to go ahead and pause the video and hit play when you're ready to check to see if you've done it correctly. How'd you do? All right, let's check. So you should have recognized that to find the first term, we would put 1 in there for I, so 3 times 1 is 3, plus 2 is 5. So our first term would be 5. To find the last term, we would find essentially the 13th term. So then we would put 13 in for I. So 3 times 13 would be 39, and 39 plus 2 would be 41. So that would be the last term. It says a sub 9, it should be the 13th, a sub 13, sorry, my bad. But the 13th term would be 41. Okay, so now to find the sum of that series, we would just plug it into the formula. So we know there's 13 terms of the series. Our first term is 5, our last term is 41, and we divide by 2. So 5 plus 41 is 46. 46 times 13 would be 598, and half of 598 would be 299. So that would be the sum of the series. Now, I want you guys to try this one on your own. So I want you to see if you can figure out how to write the sum of that series using sigma notation. And then I want you to figure out what is the sum. All right, so now I want you to go ahead and pause the video again and hit play when you're ready to check to see if you've done these two correctly. All right, let's see how you did. So for this first one, again, we need to first find the explicit formula. So we're going to take everything that we know. We know the first term is 8. You can figure out that you're adding 5 each time from 8 to 13, and from 13 to 18, we're adding 5 each time. And then we need to know what the last term would be is 43, but we're going to use that to figure out how many terms there are, what n would be. So when we plug all that information into your explicit formula, we would get this. And so I'm going to distribute the 5 through, so we get 5n minus 5. Well, negative 5 plus 8 would be 3. So now I have 43 equals 5n plus 3. I'm going to subtract 3 from both sides to get 40, divide by 5, and I get 8. So there's 8 terms in the series. So we know what n is. So now we're going to write this as sigma notation. So we would have I equals 1 on the bottom to represent the first term is where we're going to start at. And then the last term is going to be the 8th term. That's what we just found out. Now if you left your answer like this, that would be acceptable, except for you probably want to change the n to be an I, or below there, the index, change it instead of I equals 1 to n equals 1. But personally, I like to simplify it, and that's the way you're going to see it most of the time. So you want to be familiar with that too. So if you simplify that, you'd have 5n plus 3, or replace the n with an I, like I said earlier, and have 5i plus 3. So this would be the best answer. Okay, now it says what is the sum? So we're going to take what we know. Again, we know the first term, we know the last term. We just found in the previous step how many terms there would be. So we're going to plug that information into your formula. And 8 plus 43 is 51. And 51 times 8 divided by 2 would be 204. So your answer is 204 there is the series. This is the sum of the series. All right, so hopefully that made sense to you. Hopefully you got all that correct. Now let's figure out how we can use this for a story problem. So here it says a pyramid of cans is on display at the supermarket. The top row has 1 can, the second row is 2 cans, and the third row is 3 cans. If there are 10 rows of cans, I should say, how many total cans were used to make the pyramid? All right, so we want to find the total number of cans that are making this pyramid. And in order to do that, now I could figure out how many would be in each row and then add those all together, but that's going to be really time consuming. I don't want to do that. And in this situation, I don't know how many cans there are in that bottom row. But we could figure that out using an explicit formula. So let's start there. So remember, with an explicit formula, you need to know your constant difference, where we're adding basically 1 can to each row. So our constant difference would be 1. We know that there would be 10 rows of cans, so our n would be 10. And we know our first row is going to be 1. So we just plug all that into our formula there. And now if I simplify this, I can figure out how many cans there would be in that 10th row. So 10 minus 1 would be 9. 1 times 9 is 9. 9 plus 1 would be 10. So in the 10th row, there's 10 cans. Pretty simple. All right, so now we're just going to find the sum of that series then by using our formula. So again, n is 10. There's 10 rows. Our first row had 1 can. Our 10th row had 10 cans. And 1 plus 10 would be 11. 11 times 10 would be 110. And then divide by 2 and we get 55. So there's a total of 55 cans in the pyramid. So that's how you can use that. All right, so why don't you guys try this one on your own? A flight of stairs gets wider as it descends. The top stair is 15 bricks across. The second stair is 17 bricks across. And the third stair is 19 bricks across. What is the total number of bricks used in all 16 stairs? So 16 steps. So just like the previous one, you're going to want to start by finding out how many bricks there would be in that 16th step. And then use that first term and the last term and the number of steps, the 16 steps there, to figure out how many total bricks would need to be used. So why don't you guys go ahead and pause this video and hit play, just like we've always done, when you're ready to check to see if you have the correct answer. All right. Did you get it, your answer? Let's see. First off, again, we're going to have to use explicit formula. Okay, so we're going to plug in what we know. We know that there's 16 rows, so n would be 16. We know that we're increasing each row by 2 bricks, so 2 would be your value for your constant difference. And our first row had 15 bricks in it, so our a sub 1 would be 15. So then we're just going to solve this. Well, 16 minus 1 is 15. 15 times 2 is 30. 30 plus 15 would be 45. So in that last row, there'd be 45 bricks. That's not what they asked for, though. They asked for what would be the total number of bricks used in all of those steps. So we're going to use that sum of a series formula. So we know the first term would be 15. We know the last term is 45. We know there's 16 rows total. So if you're to add those together, the 15 and 45, that would be 60. 60 times 16 would give us a big number divided by 2, and you get 480. 480 bricks. So hopefully that made sense. So to summarize what we've been dealing with here in all of this lesson, between the first day and the second day here, remember we had a recursive formula for a sequence. Remember we had an explicit formula for a sequence. And lastly, we had this one here, the sum of an arithmetic series. So that's it. So hopefully all of this makes sense to you. I hope you found this to be a relatively easy lesson and all. And good luck now as you work on your assignment.